some baguette panels are left.
Okay.
So is my screen is visible?
Yes, it is visible.
Uh, okay. So these are the schematic part that I have already completed, and come on the next part, that is a SCADA panel. So under the SCADA panel, I am audible? Okay.
Yes, yes.
So in this, we have taken the current voltage and here the signal that we have taken as a current voltage, average current, measurement voltage and measurement current. Now we'll take as a uh, sub panel. So for that we go to in the library, SCADA library, and take as a sub panel here. Now right click on this sub panel and go into the properties. Here the properties you can edit your name. Sorry, the name of this group panel. What you want to put the name? Let's say I put here the name is battery inverter panel. If we want to use the label and we want to font size, so for that check on this use label box and put here the name, that is battery inverter panel. Select this. Let's say here we have taken the font size is 10 and bold it, then okay, so this will show here. One another things, we need to initialize here the path that the battery inverter take, the widgets that we will insert this, so that widgets will take the part from that path, that from the battery inverter. So here go in the properties and then initialization. Go here in the initialization. Here some path we will need to initialize. Let's say path underscore to underscore component. So that is equal to battery inverter average. Battery inverter average. Taken here as a dot. That means full stop. Now second path. So we have taken as a path two inputs. Which input we have applied? Input battery in. Battery in and then taken as a dot. Another path output for that path to output outputs battery out. Enter. And last one is a path that is undefined. Path to battery. Some value is also taken here for initialization. Because of that, let's say which value and which value it will be taken as for the parameters. So let's say VB is equals to we have taken as a 480 volt, that is default voltage. So here taken is a 450, and FB, that is a frequency, is taken as a 50 hertz, and apparent power, that is SB, that is short circuit power, is taken as a 1.6 base power 6. It's okay. Now here okay. Now double click on this battery inverter panel. So here we take as a gauge for terminal voltage. Sorry, not it is a gauge. Where is it? Yes, here gauge. Take as a gauge. Double click on this gauge. Name it as terminal voltage. For that, let's say we have taken this gauge for terminal voltage. So terminal voltage. Here data type we have taken as expression. Now here display unit. If we want to display the unit, which unit? So here we have taken a terminal voltage. So unit will be voltage. So taken as a voltage. Now go into the editing code editor. So here some value will be initialized. So here enter and taken as a VT is equals to go into other commands and take here read analog signal. So read analog signal here, search where is the VT. So here VD VQ, here VT. Select this signal and click here, insert this signal. So here API is coming, the code is coming here. So here VT is equals to read analog signal battery inverter control voltage. Display value, instead of display 00, we will put on the VT. Okay. So save this code and close this. Once again here advanced setting is increase the range of the voltage. Because of that here only 100 maximum voltage up to here 100 voltage can be measured, but we have taken as 480 volts, so we can increase the maximum range. Let's say I have taken here is a 800 volt. If you want to take as some warnings or critical ranges, so that can also take here check box. Click this check box. Let's say first warning I want to take it as a 380 volt, 380 to 400, 440 volt. 100. The second warning, we want to let's say 520, 520 volt up to 580 volt, 580 volt. Now if you have taken as a critical values, so let's say first critical value we take as a 380, 0 to up to 380, and second critical value we have taken as a 580 to 800. 800. Now okay this. So here you can see in that here these value are the critical values. Up to here 400 it will become 500, but here 380. The colors show that some critical value and some warning are adjust in this widget. Now small this widgets place here. Now this widget is working or not? Yeah, so some warning is given here. Battery inverter panel initialization file line number 13. Okay, go into line number. So here no line number is given that. Similarly for gauge we have taken as for frequency. So take as another gauge. Name it as frequency. Frequency. Go into the expression. Here display unit we have taken as a head. Go into edit code editor. Here taken as a f is equals to f, that is equals to. Now here select analog signal in the other command to API wizard frequency. So here the frequency here, this frequency, insert this frequency to here. Battery inverter control frequency, okay. And the display value instead of 00 take as a f, that is the f into fp. Okay, save this code and go again. Which type of error? F into which error is take name fb. Okay, f into fb. One more thing here we have missing here. The display value is vt into vb. Again, go into code editor and then save it. Then okay. Mm, terminal voltage, some error, we get error. Oh, this is running. Yes. Clear all this. Go into advanced setting. Taken as it's okay. No, Vigate is working or not. So here Vigate is not working. Why? Some error is occur. Which error? Battery neutral voltage panel. Name plus initialization. Try third. Panel property initialization. Line number 13. Battery inverter average. Here some error is occurred. So
There may be a spelling mistake in your initial.
yes, in battery here, yeah. So component COM. It's okay. Here some spelling mistake was there. No, once again clear this error. Now again here some error is also occurred. Which error? Line number 13. Terminal voltage frequency. Come on this properties and initialization. Line number 30. Yeah. This is the mistake. Path through, it's okay. Clear this. Not again. Yeah, now it is working fine. One more we gets taken as a for the DC link voltage. So here name it as a DC link voltage. DC link voltage. Voltage. Data type is taken as expression. Here displays unit is taken as a V. Now go into editing code editor. Enter this. So here taken as a VDC. Name VDC. That is equal to, go into search in this, where is VDC, battery VDC. So here VD and take the signal of VDC here, VAV, and here it is taken as a VDC. Insert this code here. So VDC. Yeah. Now here in the display unit we have taken as a VDC. VDC. Save it and again go to advanced setting. So here in the advanced setting, the range is taken as a maximum range is taken as, let's say we have taken as a 1200. No, okay. Mm, it's working or not? Now, yeah, it is working also fine. One more widgets we have taken. The name of that widget is battery charge SOC. So take as a one more widget. Name it as a battery charge. Battery battery charge. Go into expiration. Here charge display unit we have taken as a in the form of percentage. So take as a percentage. Now go to edit in code editor. Enter. So here we have taken as a SOC. SOC that is equal to, go into read analog signal. Search where is SOC. Battery SOC. SOC. Not SOC battery. Here battery SOC. Select this signal and insert. Now battery taken as in the display unit is taken in the form of the percentage. So here multiply by this display unit SOC into 100. Save it, close, and again go to advanced setting. So here it has taken 100%. Okay. No, it is working or not. Yeah, now this widget is working. So here gauge widgets I have taken. Now some digital display widgets were also taken for the active power, reactive power, and apparent power. So for that taken as a digital display. Here, let's say we have taken as a digital display. Name it as active power. Active power. Here, select the data type is expression, and here display unit is kilowatt. Now go into edit in code editor. Select P. Let's say P is equal to power. Power is equal to battery inverter power. So here battery inverter average control power P. Select this signal and insert this signal. But the power is in the kilowatt. The unit display is in kilowatt power. So here uh, we will display unit is P taken as a P divided by 1000. Save this code. Yeah, this widget is also working. Now similar for reactive power. So we have taken as a edit in this active power. We edit reactive power. So take as a instead of active take an a reactive power. Instead of unit display unit AVAR. Go into code in editor. Here instead of P we have taken as a Q and delete this part. Delete this part. Taken as a yeah this signal reactive power and insert this here Q active control Q. Okay. In the display unit we have taken as a instead of power reactive we have taken as a Q and save it. One more widgets we have taken for the apparent power. So taken as a control. Name it as a apparent power. Apparent power. Display unit taken as a kVA. So here instead of Q we have taken as a S symbol of S. Now delete this and insert code here. Analog signal digital analog uh, read analog signal here. Yeah, S is given that. Insert this code. Now instead of Q we taken as a S. Now save it and then so these are the digital display for the active reactive and apparent power. One more things that we have taken is a combo widgets that inverter on and off. From that widgets we can on and off the converters. So for that purpose we have taken as a combo widget. So go into this taken as a combo widget. Yet some condition is given here. Is the computer is sorry inverter is on or off. Go into this. Name it as a inverter on. Inverter on. Here two cases is given that. So here first case we have taken as a on and second case taken as a off. Go into editing code editor. Here if input value taken as a let's say it is a off, taken as a off. Delete this. Hmm. First condition that we will go into the SCADA input. Because of that we are controlling the input of battery inverter from the SCADA input on and off. So go into this, select here SCADA input. Here condition is given that on and off. So select this and insert this code source. So here battery in out 00, that means it is in the off condition. Now second condition taken as a on. So here in this, for on condition here we have taken as a 1, take as a 1 and enter. Now insert this code here. So here battery inverter in and on. Okay, now save it and close this. Once again it go into advanced setting. So here some custom code is given that we check here on start button, and here some value is taken. Let's say we get value which what you want to display. So first case we have taken as a off. Now go into here off. So put the this SCADA value is 0, enter, and insert this code here. Here battery inverter on 0 and save it. Now seeing this widget is working or not. So here this is on. Yeah, it is working. Off. Okay. One more combo widgets we will take for the inverter condition, inverter mode. Because of that we want to operate this inverter in first case. Let's say we want to operate this inverter in the grid farming mode, and in other condition we want to, or we want to check in the grid following mode, grid farming and grid following mode. So for that purpose one combo wickets will also taken here. Control C, paste here, control B. Name it as inverter mode. Inverter mode. Here condition taken as a first condition we have taken as a grid forming. Grid forming and grid forming, and second is taken as a grid following. Grid following. Go into SCADA input here. Now here first input value, let's say we have taken as a grid farming. Grid farming. Delete this. So for grid farming and grid following, one contactor is also used and the mode is also used. So here two code will insert, one for contactor and another for the SCADA input, that is battery input mode. So first take as a contactor setting. Uh, go select this contactor and insert this value. So here switch control first for false mode, let's say, and also false mode. So here we have taken as a, let's false. Instead of false, one taken as a true and another is taken as a false. True. 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 Now again go into the SCADA input. Here SCADA input mode. Select here mode and insert this panel. Here we have taken as a control. Okay. Second case we have taken as a grid forming. Grid following. Grid forming. Grid grid following. Delete this. Instead of this, we need to put here mode condition. Click here one and insert this. So here battery inverter one. But before this, one contactor switch is also used. So here, go into the contactor setting, close this contactor and insert this value here. Here true and here. This is also taken as a true. True. Delete this and save this code and close this. Once again go to here, go to the advanced setting. Here it's on. Widget value we have taken as a first. Go into here. uh, Grid forming, grid grid following. Now insert the code here. First for contactor. So take as a contactor. Insert this here taken as a true. Yeah, capital as well. True. And second we have insert to mode setting contactor and one is the SCADA input here mode setting. Insert this setting. So here battery inverter mode. Now save this. Now need to check this is working or not. Yeah, this widget is working properly. Okay. Load this. Now, if we want to change the supply source, power, and frequency without going the SCADA panel, without going to the source. So for that, we need to slider. So here we have taken the slider for that purpose. So let's say here we have taken the slider and name it as first is name it as a B reference. B B reference, that is voltage reference voltage. Now here properties taken as a because of the voltage maximum range we have taken as a 800. So here put as a 800 and go to here edit and SCADA input. Insert here input voltage, that means P reference voltage. Click here, select this voltage reference and insert this. But here instead of by default voltage 480 voltage, we will put here input value. By changing the value slider, the voltage can be changed. So taken as a input voltage and save this. Then again go to advanced setting. In the advanced setting, we have check here this. and go into the Vigit value. So here we have taken as a Vigit value is VB. Now insert the input voltage. So here this code is insert here, but here instead of 480 we take as a Vigit value. Vigit value. Now save this and close. Now we need to check this is working or not. So here it is working. Now increasing the voltage. Yeah, it is working. No error is occurred here. Okay. Now close. For that, if we need to the frequency, so copy this and paste here. Name it as frequency reference. F reference. Here the maximum value taken as a 100 and step size is 1. Go into the SCADA input. Delete this. Put here frequency reference here. Select this frequency reference and insert this code. Hill SCADA here. Instead of by default frequency, we take as a input value. Take as a input value. Now save it. Once again go to advanced setting here. Then this taken as a F D and here insert this code insert here taken as a Vigit value. Then save it and close. Now it is working or not, we check here. Yeah, so it is working this Vigit. One more slider we will take for two slider, take for one for power active power and then second for the reactive power. So copy this. Sorry, already I have copied. So paste this. Name it as P reference. P reference. Now the maximum value is taken as go into code editor. Sorry. Yes, okay. No, first we will take here and after that we will go. So here P reference, select this and insert this code. Instead of this, we put as the input value. Input value. Save this one again, close and then again open. Here taken as a minus. Let's say we have taken as a range of minus 1600 to 1600. 1600 and go into advanced setting. Then code in editor. Here instead of Vigit value VB, we have taken as a P. Insert this code instead of here. Taken as a Vigit input. Vigit value. Now save it. Check it. This is working or not. No, some error is creating here. Which error? P reference on starter handler. Okay. On starter handler. 2000. Go into the basic setting. Here, because of that, The unit is taken as a power. So here multiply by 1000. It is multiply by 1000 and save it. Similarly for widget value, so here go into code editor, taken as a widget value into multiply by 1000. Save this. Now clear this error. Check this, it is working or not. Yeah, so it is working. Yeah, it is working. Mhm. Now once more error is on starter handler is not defined. Okay, okay. Taken as a is equals to shift equals to. Now save it. Clear this error. Fine. Now it is working. Not working. Now which error is occur? No p is not defined. Hmm? Small p. Oh, where? No, no. It is a taken as a capital P. Your widget value. Yeah. No. P is equals to. Hmm. Taken as a p, that is equals to. Insert this code. Here taken as a input value into 1000. Now save it. Okay. Again oh, go into the advanced setting. Yeah, widget value is equals to p and the widget value into, yes, it's okay. Okay. No, some p reference kilowatt on starter handler. Yeah, okay. Go into advanced. Don't put here. They are taken as a 0.0. Okay. Yeah, now it is working fine. Similarly for reactive power control, we are putting taken as a Q reference. Q reference. Okay. VAR. R. Go into a code editor. Taken as a Q. Select Q reference and insert this code. So here instead of 0 we put as input value into 1000. Save it, close and again open. So here dot SCADA input, insert this code. Now we get value into 1000. We get taken as a we get value into 1000 and save it. Then close. Now check it is working or not. So yeah, now it is working fine. Close the simulation. So up to here, participant, if you have any doubt, any question, so you may ask. Now taken as a trace graph, trace widgets graph for showing the graph of terminal voltage, frequency, power and reactive power. So for that, go into taken as a trace graph. Go into this, take here. Name it as, let's say here taken as a terminal voltage. Terminal voltage. This is in the per unit. Now here signal is taken as a expression. Go into edit in code editor. Delete this things. No. VT. VT is equals to, go into other commands taken here. Where is VT? Here. Select this VT and insert here. Control VT. Yeah. Now display value. So here display value. Okay. Display value. Instead of display value, we taken as a VT. VT. Now save this and close. Once again, taken as a advanced setting. So here a time window we have taken as 100 and auto scaling is okay. Remaining thing is same. Okay. So reduce this panel. Okay. Now one more trace graph is taken for the frequency. So copy this and paste here. Name it as a frequency per unit. Frequency expression. Go into code editor. Here taken as a, instead of BT, taken as a F is equals to, and delete this. Delete this. Take as a frequency. So where is the frequency? Here. This. Select this signal and insert here. What? Yeah, control frequency. Here display value is taken as a F. F. Save it. Close. In the advanced setting. Yeah, it's okay. Auto setting. Check this is working or not. These widgets. So these widgets are working. It's okay. Fine. Now two trace graph is taken for the three one apparent power. Now taken as a trace graph. This name this trace graph is active power. Active power. Units of this active power is, let's say, we have taken as a kilowatt. Going to signal, taken as expression, then edit in code editor and delete this. Here taken as a P. P is equals to signal, power signal. So here, yeah, control power. Insert this control power here. Yes. Yeah. Now display value. Display value that is equals to P divided by 1000. Save it. Close and go again to advanced setting. So remaining things will be here. Windows ID is taken as a 100. Okay. Now reduce it. Copy this and one for reactive power. Take it as a name it as a reactive power. Reactive power unit AVR expiration and go into code editor taken as a Q. Now taken as a Q is reactive power. Select reactive power. So here power and here control reactive power. Insert this value and instead of display value Q divided by 1000. Yeah, now save it and it's okay. Here active and reactive power. Now for apparent power, control C and here paste as a control B. So name it as a apparent power. Stress graph. Yeah. Apparent power. Taken as a S. Select this signal here. Control average here. This signal control power. Insert this signal. And here the display value we have taken as divided by 1000. Save this and close. Now check this while these widgets are working or not. So okay, every widgets is all the widgets are working fine. No error is here. So up to here, if you have any doubt, any question, you may ask. Otherwise, I proceed further. What? Your voice is not coming properly. Okay. Now go into SCADA panel here. If
Amit Kumar Roy, please mute your mic. Amit Kumar Roy, please unmute your. Sorry, mute
so here
your
we take as a
mic,
inverter
please.
enable inverter on. So here now this these widgets are working. Here I will now inverter is on. If we will on this inverter, no, now it is work. Then the terminal voltage of the inverter is 480 volt because we have taken as a by default 480 volt. But if you we want to change this voltage, so here by changing this voltage we can directly change with the help of this slider. And the frequency here 50 hertz. If you will change with the help of the slider here 50 hertz, so here the frequency is also changing, and this in this graph it is also changing, and the terminal voltage is changing. Now one more thing. Now here inverter mode that is working in the form of the grid following. Now it is we want to work this inverter mode in the grid forming. So for that here we have connect this into grid forming, and the grid forming we change the value. So here go into the battery inverter mode taken as a stop this. Why it is not working? Inverter is on, and this is in form of grid forming. So here the now it is forming in the form of the grid. So here two modes you can operate: grid forming and grid following. Here when we are connected in the grid following mode, so here active power and reactive power is zero. But when it connects in the grid forming, so here the power is coming and the trace graph is also working properly. So here total the schematic and the SCADA panel of the completed of the battery inverter average model. Up to here, if you have any doubt, any questions, so you may ask. Otherwise, I stopped and hand over the session to the Dr. Mr. Samsher Ansari sir for the microgrid demonstration. So if you, dear participants, if you have any doubt, any questions, so you may ask.
Thank you, Fezgur sir.
Perhaps there is no doubt. So Dr. Sorry, Samsher Ansari sir, please hand over your
Yes,
session. So now I am saving
stop
this.
sharing. I will start
Okay,
discussing
okay,
the microgrid.
okay. I am stopping my sharing. Okay, Sanjay sir, I am stop sharing my screen, so you can hand over your session.
I think my screen is visible.
Yes, your screen is visible.
So, so now again, I'm back here to discuss or demonstrate a microgrid, which is available in the example section of the Typhoon HIL. So just go to example at the microgrid here. Sorry, in the microgrid examples here at the microgrid examples. So two examples is present. One is terrestrial microgrid example using generic components, and another one is present with plug and play microgrid library and testing of microgrid controller. So this one I want to demonstrate so that you will have a clear cut understanding about the microgrid library of the Typhoon HIL Control Center. So just I'm opening this one. So now, if you are quite familiar with the microgrid, then you may know that microgrid can be operated in three possible mode of operation, that isochronous, grid connected, and islanded. And if you talk about the control architecture, then we can say that microgrid having three types of control structure. First one can be centralized control, then distributed control, and hierarchical control. So here the microgrid which is available in this time on my schematic editor, this one is having centralized microgrid control architecture. So in this microgrid, we have one ESS based generation, then one wind power plant, one PV power plant, one DG means diesel genset, and three load. These loads also different types. One is constant impedance, interruptible load, and variable load. So these three types loads also we have used. These are the transformers so that high voltage and low voltage side we can match. And this one is the grid. Okay, this one is the grid so that we can operate this microgrid in grid connected as well as in islanded mode. This one is the PCC. In this PCC, we have some monitoring facility like synchronous sync check. Okay, so inside this PCC, these things is created to check this synchronous sync with microgrid uh, and utility grid, so that appropriate action will be taken to connect or disconnect the grid or microgrid. Okay. And this one is the microgrid central controller. This is the brain of this microgrid. From this many conditions are defined. Using that, we can connect and disconnect a particular distributed energy resource. Also, we can make a particular distributed energy resource to behave like a master, so that others distributed energy resources will follow it in islanded mode. So now if you will observe a little bit, then you can see that this ESS and this diesel genset having three terminals here. Two is incoming and one is outgoing. Okay, two is incoming, one is outgoing. So two signals are coming here from the microgrid central controller, and one signal is going to the this PCC, so that they can handle the islanded mode of operation and grid connected mode of operation. That means what I want to say, that this ESS and diesel genset can be used to form the grid, so that islanded in islanded mode the microgrid can be operated. So what are the ratings I have been used and which type of model we have used, so that we can see here. This one is the battery inverter. So just if you will click inside this one, so you can see this one is switching model. So all this distributed energy resources, energy components we have used, all these are belongs to switching models. So this microgrid can be used to test physical microgrid. Now this rating of this one ESS is 1.6 MVA at 480 volt. This wind one is 500 kVA at 480 volt, and PV is 250 kVA 480 volt, and this diesel genset is 2.2 MVA at 480 volt, and this constant load is having uh, this constant load is rated at 700 kVA, 700 kVA at 480 volt. This interruptible load, this one is 480 kVA, and this one is variable load. So this one is up to 460 kVA at 480 volt. So if you want to analysis the one more thing I want to say, that it is, even though it is a centralized control architecture this microgrid is using. But here also we have to take two types of controller. One is primary controller and another one is secondary. Primary controllers involved with this distributed energy resources so that the terminal voltage of this distributed energy resources can be regulated, right? So this controller we can say that it is the primary controller. So next, this is the central controller. Central controller mainly responsible to regulate the voltage, frequency, active power, reactive power of the entire microgrid. Okay, so here also some controlling part also present. So this one, if you will see that active power reference and reactive power reference is controlled through EI controller. Okay, and some special conditions are used here. You can check in the library so that you can understand what are the conditions, different conditions they have used so that islanded mode and grid connected mode, sometimes ESS can be used for grid forming, sometimes diesel generators can be used for grid forming. Like that situations can be created. So now I will compile this one. And a very interesting thing is here to tell that this model will only operate with HIL 602 plus model or 604 model and 606 model. Currently, we do not have in our office this model, so I'm running this one on virtual HIL device. Just wait, it is compiling. It will take some time. Now I will select load model to virtual hill. So this one we have to select, okay, because this panel already available in the example. I will zoom it a little bit. Yeah, I think it is visible. Now I want to how I will operate this microgrid. So first look here, the grid forming. Which one we will use as a grid forming? So options is here, battery inverter or diesel genset. So anyone you can use when we will operate this microgrid in islanded mode. So here operating mode is grid connected as well as islanded. Next, this one is very important. This wind power plant, we have to connect or disconnect that facility also. We can make. So same thing is made here. So first I will operate this. I will run this model. So now it is running, but no output is coming. You see here, output is here, and also uh, yeah. But this one 909 kilowatt and 216 kVAR power is coming from the grid, okay, main grid, because this constant load is here. This constant load is connected, and no microgrid distributed energy resources are active during this. So because of that reason, this load, constant load, is taking power from the grid. So now what I will do, I will connect this with power plant. So just enable this one. So now we can see that this one is getting activated. Now it is activated. So wind power plant is activated and it is operating in grid following mode. And the second is PV power plant also we can switch on. So I'm connecting and enabling. So just wait and you will observe that it is going to connect. Yeah, the PV power plant also activated and it is giving power to the grid. So now earlier it was 900 something kilowatt power, but now from the grid, this microgrid is taking less power, 298 kilowatt only. Okay, so that it can meet the demand of this constant load. Now I want to switch on one inverter. Okay, so this one I will switch on. You can observe that here is 298. Once this inverter will, battery inverter will switch on, this increase. Someone's mic is on, please. It will be good of your mic, please. Amit Kumar Roy, sir, please switch on mic. So now this battery inverter is also switched on. So you can observe that here from the grid, it is taking only 101 kilowatt power. So now in grid tied mode, the microgrid is operating. And I want to disconnect this microgrid from the grid and want to operate in islanded mode. So for that, what we need to do, just here, we have to take, we have to select islanded. I will wait for just for a second so that it get stabilized, because still it is decreasing. That means some balance of energy flow is going on. Yeah, I think it is stabilized, so we can it in islanded mode. So just I will select here islanded. Okay. Now you will observe this go down, means it will become zero, so that the microgrid will not take any power from the uh, main grid. So you can see here that this power is decreasing. Yeah, you can see that from the PCC, no power is flowing. That means our microgrid is completely operating at islanded mode. And here the battery is playing a vital role to form the grid. So whatever the voltage frequency uh, reference generated ESS that is used by as a reference by this wind power plant and PV power plant. If we want to increase the load, easily we can do. So you can see that this one will increase its capacity so that generation and demand load will be balanced. This one is operating at 490 kilowatt and rating of this wind power plant is 500 kVA. So this one is operating at maximum and this wind power plant is operating at 5 kilowatt while its operating capacity is 250 kVA. Okay, and this one is increasing its power generation because already we have switched on one interruptible load. So demand is more. Because of that, this ESS is increase its generation. Now I will switch on this one diesel generator. So you can observe here this diesel generator will be switched on. You can see that this one is switched on and working in the microgrid. So in this two ESS as well as a diesel genset, among this any one can be operated as a grid forming inverter and rest will be the grid following inverter. So in this way we can operate our microgrid in Typhoon Hill Control Center manually. But if you want to make it completely operate in automated way, for that you have to make some algorithm in the schematic editor, which will be interactive with the SCADA panel so that this entire microgrid will operate by its own. We do not have to select islanded or grid connected battery or diesel genset for grid forming. Some load we need to on or off. That things we do not have to do if we will design such a algorithm in schematic editor. Okay, so in this way we can make our microgrid and we can perform the operation of microgrid. So if anybody have any questions, they can ask. Dear participants, if you have any questions, you can ask.
So, I wanted to ask regarding the state space matrix. So, while compiling, there was a like message in the message log that it's calculating the state space matrix. So, can we get that? Like, can we access that? What are the exact values of that matrix or something?
State space matrix. In this example or in somewhere else?
Actually, when you started with the compiling, then only it started.
Okay, okay. Here means that is here, right?
Right now, I can't see, but
This one will show the details of the compilation. Okay,
okay.
means how much core it is using, how much SPC it one this
Yeah, yeah.
entire matrix. using. So all these informations will be here. Machine solvers, parallel DTV violations is here or not. So like that, all informations you can get here.
Okay, so actually we cannot have that exact that matrix. We cannot have some command like that to get that.
No, we are having a state space block available in our library. You can have in the signal processing. In the discrete, when
Okay,
you go, there is a block of state space.
all right.
Okay, or you can simply type in your library search box, just type
Mm-hmm.
state space, then you will have a block set of discrete state space, and it is having all the matrices A, B, C, and D.
Yes, yes, you are here. You can see
Yeah,
this
in
one.
the library you can explore.
Okay,
This one.
okay.
So,
Thank you.
and
Yeah,
if you are able to see my screen, so here it is
Yeah.
available.
show them. Please.
Yeah.
Yeah, state space. Just type simply state space. The block will come.
Okay, ma'am.
Yes, sir. Okay, thank you.
Any other questions? Okay, then today it is 5. How much time it is?
No,
3:20.
no, it's fine. You done, sir? You're from your side, Shamsher, sir.
Yes, sir.
Yeah, okay, okay, fine.
No, you can stop, sir.
Just let me
Take
check.
the permission and stop.
Vivek sir or Manoj sir, is there anyone available from the host team? I request anyone from host team is available in the meeting. Kindly respond. Oh, actually, we guys are before time today.
Okay, no issue. You can ask your questions.
Yeah, if you have any
We
questions,
will
yeah,
make it interactive, so
yeah, yeah,
your
definitely,
doubt will
definitely.
be clear.
Yes, you're
Because
right, sir.
I know very young researchers are present here,
Yeah.
and they might have many questions. So if you are having any kind of doubt, please you raise your hand or you ask the questions so that we can reply.
So I do have another question, but it's not related to actually the exact these examples.
Yeah.
I started with a DAB dual active bridge converter design, and in that I had to give a space between the two pulses, like phase shift. So I was
Okay,
not able to
means you want
implement
some
here.
delay.
Yeah,
The
for the
two
delay.
pulse you want some delay.
Yes, yes, yes.
You for that, where from you are, ma'am? Which university?
IITBHU.
Okay, in IITBHU we have given you this model, right? Sorry, HR device.
Yeah, it's that.
So okay, ma'am, you will you just raise a ticket to us, okay, or contact on WhatsApp or helpline.
Okay,
I will
sure.
take
Okay, okay. Thank you, sir.
issue about that. So participants can ask questions, no issue. We are here.
Good evening, sir. Hello.
Yes, yes, ma'am. Continue.
Sir, I have a question. Sir, actually, this Typhoon software, I want to know the basic working, मतलब how is it working? It is a hardware and software interface. So I want to know the basic working of this Typhoon HIL software?
Basic working, ma'am, whatever we are giving lecture from first day to today.
Yes, sir.
Now for today one, it was a little bit advanced because microgrid
No, no, sir. I'm.
part is involved. But
Okay.
yes, yes, you
I just
ask.
want to know how is it working. I mean, we are working with the Typhoon Hill interface. So how is it working? I mean, there are 64 analog inputs and 32 analog outputs, and how we are giving inputs and how we are taking outputs. I want to
Okay,
know.
okay, okay.
Yes, yes.
No issue, I will see. Again, I am showing already in morning times. I think
Yes,
I have
yes.
shown it, but
Yes.
no issue. So suppose this one I am opening. Okay,
Yes.
and this one is simple inverter, right?
Yes.
And this the PWM I created so that I will use this model. Then this one just will work as an inverter. Okay, inside the modulation I am not considering because my modulator is outside, right?
Yes. Yes.
So just I will compile this one and I want to this VA1, IA1, okay, this one and this one also this one I want to take outside of the simulator, right?
Yes.
Just I'm compiling it. Even this one, this digital probe, it means whatever the signal or digital pulses are generating here, that also can be taken out. So how we will take? I'm just so now I will take one capture. Okay, this is the minimum which require to work with SCADA panel. So this one I want to see here, and this voltage also I want to see. I have to give some source because at schematic I have not this value. So now it is running. Okay.
Yes.
So how to take these signals out? So just look at here,
Yes.
out controls and digital outputs. Okay, analog outputs and digital outputs. HIL 0, HIL 0. So just click here, HIL 0. Okay. So this one, how many outputs we can take here? 16 analog we can take. Okay.
Yes.
This
Yes.
is all about HIL 402. So in 402, 16 analog we can take out at a time. So just which one I want to take, that will appear here. This is IA1 I want to take, and I will put here 100 or 1 or 2 or 3 depending on the value of IA amplitude. Okay, if IA1 amplitude is 100 volt, sorry 100 ampere, so we cannot take 100 ampere outside, right? Because
Yes.
the simulator have a limit plus minus 10 volt. So for 100 ampere amplitude is there, so we will divide by 100. So at 1 ampere will go out, right?
Yes.
And just we do these things, and at outside of the simulator there have pin number IO1 and
Yes.
ground. So we will take the DSO, and one pin of the DSO will hold at IO1 and at another one is at ground. So this signal will appear on your DSL. Okay.
Okay, sir.
So in this way, all these signals you can take out. This scaling depends on the amplitude of this. Okay. So that it can give only plus minus 10. If you will not do proper scaling, then you will observe different type of signal on your ear, and you will think that what it is coming. Like that. Okay. If you want to take digital output, for that same thing here, just we need to enable, and here we have to select. So digital probe, from digital probe we will we wanted to see. So 6 pulses were coming there in the schematic panel, schematic editor. So 0, 1, 2, 3, 4, 5. So suppose digital probe 1, 0, this one I want to take outside. Just you have to select here and close, and take your probe at the outside of the simulator at pin number DO1, and another probe in the ground. So this pulse will appear on your DSO. Okay. Yes, madam. Hope you understand.
Yes, sir, I understand. Thank you so much, sir.
So any other participants also can ask questions, please.
Actually, we have received a message from Vivek sir that he is facing some network issues. Vivek sir has posted a message on the chat box and he is facing some network issues. So if there is no question from participant side, then we can conclude and we can wind up our session here only.